Hello everyone. Today we're going to be solving question number 29 from the 2023 chapter competition sprint round. The question reads, the area of a rectangle is 32 centimeters squared. What is the least possible integer perimeter of the rectangle? So essentially what they're saying is you have some sort of rectangle like this. Let's say this is side length. Well, this is going to be length, and let's call this the height. So then this is also the length, this is also the height. So you're given that length times height equals 32. And we want to minimize the perimeter, so the perimeter is 2 times L plus H, because perimeter is basically the sum of all the sides. You have 2 L's and 2 H's, and this should be, we want to minimize this. Okay. So to start, let's think about this. How is the perimeter of something minimized given it has the same area as another figure? Well, the idea is you want to make L as close to H as possible. So basically you want this figure to be as close to a square as you can get it to be. And if you've ever, you might have seen this before, that yes, a square with the same area as a rectangle has a smaller perimeter. And you can see this in this case too. If you just look at the integer possibilities to get this area of 32 centimeters, let's say length, height, and this is the perimeter. So you can start from the outside. So by outside, I mean like the farthest apart numbers. So if the length is 1 centimeter, height is 32, well, the perimeter is 1 plus 32 times 2, that gives 33 times 2, which is 66. Now if you try 2, you get 2, and then for height you get 16. As you can see, you increased the length by just 1, but the height goes down by 16, like it's going down by a factor of 2. So that's why the perimeter decreases when L and H get closer to each other. So you see 2 plus 16 is 18. 18 times 2 is 36. You can do the same thing with the last pair, 4 and 8. So these are basically anything that multiplies up to 32. That's what we're getting here. So L and H such that LH is 32. And then 4 plus 8 is 12. 12 times 2 is 24. So the perimeter you get here is 24. Now, again, as you see, L and H are very close to each other. So the closest L and H get is when L equals H. That means L squared, if you substitute L in for H, is 32. That means L equals 4 root 2. So this gives you a perimeter. This is going to give you the lower bound on the perimeter, right? Because once it's a square, it's going to be a square because L and H are equal. The perimeter can't get smaller than that for the same area. And the idea is essentially any area above whatever we're getting here as our lower bound, any perimeter above this, up to, let's say, 66 as our upper bound. There is a larger upper bound, but we're going to leave it at 66 for now, is a valid perimeter for the rectangle. So in this case, you're going to get 4 times the square, so you multiply one side length by 4, you get 4 times 4 root 2, that's 16 root 2. You can estimate this, or this is one really good fact to know, is that root 2 is approximately 1.414. So you can just keep the 1.4 part, and then 16 times 1.4, well, that's 16 plus 6.4, which is 22.4. So that tells you the perimeter must be greater than 22.4. Now the least integer greater than that is 23, and that is a very possible answer. And if you don't have time to check if it is a possible answer, once you figure out there's a lower bound of 22.4 and you see the perimeter of 24 is viable, just put in 23 and go with it. But you can also check if you have time to do this on the actual competition. So I'm going to show you how to do that. So let's see. I'm going to erase all of this. So one thing very important to realize while I'm doing this is we're only being asked about having the least possible integer perimeter of the rectangle. We're not being asked for the sides to be integers or for them to, like they will have to sum to an something that has like a denominator of 1 or 2 so that this perimeter turns out to be an integer. But the sides aren't required to be, what do you call it? They aren't required to be integers. So now what we're given is, this is basically the 2 check part. So now you can just submit 23 and go again if you don't have time to solve this on the actual exam. But here what we're going to do is check this. So 2 times L plus H equals 23. That gives you L plus H equals 11.5. And also, L times H equals 32. So you might know how to do this if you worked with quadratics before. That's usually the easiest form to get this into. So if you know the product and you know the sum, what you do is you substitute one in for the other. So to make this easier, I'm going to make L equal to 11.5 minus H, and then we substitute that in here. So you get 11.5 minus H times H equals 32. This gives you 11.5 H minus H squared equals 32. So H squared minus 11.5 H. I'm moving everything to the right side. Plus 32 and the left side just becomes 0. But I've moved them. I just flipped which side is which. Now use the quadratic formula. If you remember, the quadratic formula is negative b plus minus square root of b squared minus 4ac all over 2a. So I'm going to put an optional here. And these, b, a, and c refer to the coefficients. So a is just 1, b is negative 11.5, and c is 32. This comes out to be, let's see, 11.5 plus minus 11.5 squared minus 128 over 2 times 1, just 2. And basically we're trying to confirm that yes, such side lengths do exist. So that means that these need to be real side lengths in the sense that this over here, we just need to confirm, is not going to give you an imaginary value. So that means the square root must exist without needing to consider imaginary numbers. So 11.5 squared, well, if you know the trick for this, when you have something ending in a 5, you take the first 2 parts of it, like all the digits to its left, and multiply that by 1 plus itself. So in this case, 11.5 squared will be 11 times 12 gives you 132. And this back part here is going to be 25. So 132.25 minus 128 all over 2. And you can see this is going to be the square root of 4.5, which is going to be, this is real. If you're not sure what real and imaginary means, real essentially means that it's like everything under the square root. So b squared minus 4ac is greater than 0 because you can't technically take the square root of a negative number. And it's imaginary if everything under the radical, so b squared minus 4ac is negative. So that means that there are 2 side lengths that exist, and you can see these are very clearly not just fractions. They have radicals in them, and it's not a very pretty radical either. So such side lengths do exist, and thus 23 is indeed a viable side length. Or sorry, perimeter.